Hello, we're talking about our vector accelerator. So since last meeting, we've completed our top level of the accelerator and ran it through simulation to verify all of our connections. We have different tests to test the submodules as well as the top level, and we test the supported operations, which are mentioned on the next slide, and ensure that our banked register file and the lanes are all working together in conjunction to be able to execute these sort of pseudo instructions in parallel. The right side is just an example screenshot of our printouts for writing to the registers, doing some operations internally, and then reading from those registers to verify the results.
So these are the supported operation for our vector accelerator. First, we support vector add, subtract, and multiply as element wise. And we also support vector scalar as subtract multiply, which is basically just using one scalar and one vector on the other side. Since this is accelerator, we should support writing to our vector register file, which allows us to use data to our ALU computation. And it also is able to read from the vector register file, which is gonna basically contains all the outputs from our vector computation. So we ran our place and route on Sky 130 flow. This was running in clock period of 30 nanosecond. We got 40K micrometer square and power of 1.083 milliwatt. Since we have to compare it to other design, we chose like similar vector processor that does the job. And then it got a million micrometer square and power of around 3 milliwatt. As you can see, we got about 30 times more area efficient and 3 times more power efficient as well.
And so our next step for the remaining week or two is going to be trying to support dot product operation, which would then allow our accelerator to do matrix-matrix multiply. And so to do this, we're going to be splitting out the adder and multiplier of the ALU, and so we can kind of accumulate in the second register. And then we're going to try to keep it somewhat of a similar structure and within the same cycle so that we can still support the vector operations that we had previously. Thank you.